Hello, I'm going to explain how to use Armadillo from R. To do that, I'm going to use the Armadillo for R package that I created. And to explain all the steps, I will start with the basic setup, including configuring the C++ tools needed to compile C++ programs from Windows. Here I created a Docker instance with Windows. Why? Because most users use Windows. Here I'm running a Manjaro Linux, and I know that's not super common. So here are the steps. I will download R normally from 0. So I'm running this from the browser because this is a virtual machine. So I download the base R from the official R website, right? And I also need the RTools to be able to compile the C++ programs that I am going to create, because Armadillo, it's a C++ library. And I need this one. Okay, so once this installs, I'm going to resume the video. So now I'm going to pause. Okay, so the installers have been downloaded, so I install R first. Okay, so I proceed to install R with the default setup, and just click next all the time. And again, now I pause this. Okay, so the installation moved forward. I just paused the progress bar to save you some time. And it's almost ready. And when it's done, I finish this. Okay, I canceled that. I accidentally opened it twice. So now I go with the RTools. This is something you only need on Windows. With Linux, the C++ compiler, it's already provided, same with OS X on Mac, so this is a Windows only step. Okay, so this should install in no time. I check that it's recording. Yes, it's okay. Okay, there is the RTools, same thing, just next all the time. And same thing, I'm going to pause this. Okay, so the RTools are ready. So what I'm going to do now is to open R. Okay, should be there. Sorry. Okay, there is. So I'm not going to load the RStudio and nothing like that, and just proceed to install packages. So I need 2 packages for this: cpp for R for the C++ headers. Right, and I will install this from the default mirror. And now I wait until this completes, so I pause this again. Okay, it's ready. So now I install Armadillo for R. So I am going to also post this. Okay, so it's ready here. So now I'm in condition to start creating another package using Armadillo and C++ code. So in order to do that, I am going to split the screen here, and here I'm going to open the documentation. Okay, that's the official documentation. So I will start with the template exactly like here. So if I type get working directory, okay, I'm in documents, and here I will call Armadillo for R and call the package template function. And here I will give this a name. It's going to be video Armadillo for R. That's going to be the package name. Okay, so that created a folder. I can see that here in documents. Okay, it's there. It's a package skeleton. Okay, so it's recording, it's all good. So now I type set working directory and I go to this video Armadillo for R. There is. So now I can open files here. And if I go to dev, here I have a first script to load the package and check that any changes I implement are actually working. Right, so this uses the DevTools to test continuously, right? And you can run this later. And if I explore the source directory, here I need to change the extension. Here I have a few files. This needs some explanation. So main, it's the main C++ file. So this is calling the headers, the C++ headers for R, the CPP for R, the Armadillo headers, that's the Armadillo for R, and then this is using the CPP for R namespace, and it's including two headers, one for OLS and another called your functions. So I am going to open the script. So if I open this OLS, this provides two examples divided in like step 1 and step 2. The first one is doing the OLS formula to obtain the OLS estimates like the slope and intercept using the Armadillo syntax like MATLAB. And then the second part, it's the same. One function, it's a repetition of the other with a minor difference. The first one here, the output, it's a matrix, and the second one, it's a vector, but both are calling the same initial function like stage 1, and then stage 2 you can either return this as a matrix in R or return the same as a vector in R, but it's calling the same underlying function. And then if I open another script, I can go to your functions, and this is a placeholder that I put in the template. So here you can add your own functions. So this is similar to the other script, right? With the difference that this here is calling a main header. So if I go here and look at what is this header, you need to include that in case that you need anything like a dedicated library, etc., etc. So this is more or less how to configure everything to start using a package. So now, sorry, I can delete that. I can comment that, or even delete that file, right? It's totally fine. I can go here, I can delete that, and then if I delete that, I need to also open the main.cpp. So this main.cpp is going to create a single binary, and all the H files are headers that are called by the main file, right? So now I can just comment that with // or just delete that, and then save the changes with Control S. Oops, sorry, maybe just a file save. Okay, that's it. So if I want to start like checking this, all the changes I've made, I'm going to dev. This is a part of the template. So I will load this, load or install, right? So if I select the first part and run that with Control Enter, sorry, or just, sorry, I'm on a virtual machine, I'm going to just paste that in the R console there. Okay, it needs to install some packages to install DevTools, so I'm going to post this again. Okay, so now it's ready. So in order to keep track of the changes I made, I need to register the C++ functions and document, right? And then I can load the package with load all or just install. So the template, I decided to add this in the template to make it more simple when you need to install. Once you are done with the development part, and just need to install the package and start using that and run your functions. Okay, so I'm going to run that. Oops, sorry. This is something I need to update in the template later. This is from an old version. Okay, so I'm going to do that to just register from the current directory. Okay, so now it's trying to compile, but the register step failed, so I need to cancel this. I'm going to maximize this window. So I'm going to stop that. Okay, so now I paste my commands. Okay, that's good. So now it registered the functions correctly after I made the changes, and now this needs to compile again. This is why we installed the RTools, and then this is going to document the functions, so then I have access to the functions as a user. Okay, so it's compiling. It's inside a virtual machine, so I don't expect this to be super fast. Okay, but okay, it's there. Okay, half a second to compile. That's good. So now I need to load this function to be able to see them. Okay, so I paste that to load the functions. Okay, so my functions are these. No, not this. That's the main file. Oops, sorry. Okay, that's the main file. I need to see this. Okay, so to test this, I need a vector, the response vector, and a matrix like the design matrix. Okay, so here let's say I want to do something like a regression, like let's say we define a fit1 to compare, and we do an LM, and we want to explain miles per gallon as a function of the weight of the car using the empty cars dataset. Right, so here we expect that heavier cars have a lower value for miles per gallon. Right, so okay, so now we can see the coefficients for this model right there. Okay, that's what was expected. Heavier cars use more fuel. Okay, so now for this C++ function I created, of course this is just an example. This is not the best use case for Armadillo because R already provides the LM function, so reinventing the wheel is not the best thing to do. But if you want to replicate a scientific article, for example, and you need to type something like in a MATLAB way that can be more convenient than the R syntax, or where you need the speed from C++, then you use Armadillo, not to reinvent things that R already does well. Okay, so here I create a vector. So I'm going to create a vector y that's going to be empty cars, miles per gallon, and I'm going to put this as a matrix, as a column vector, right? I hope to be making sense, like that, right? So for the computer it's a matrix as a data structure, but it's a column vector in the econometrics notation. Okay, and now I need an X matrix. So here I need to define a matrix where I am going to do this. I will first use the cbind function, and I'm going to create a vector of ones with length 32 for the intercept, and then I pass the empty cars miles per gallon, and this it's going to have two columns. Like that, right? So now I can see what I created, and there is, sorry, it's col. Sorry, and calls. No, sorry. My fault. I'm using cbind, so this is like that. It's not. I'm not calling the matrix function. Sorry. So now if I see the class of X, it's already a matrix, and now it's okay. Okay, there is. Okay, perfect. So now I can call this function. It's but I cannot call the OLS underscore function directly because it's not exported to R, but the second one and the third one are exported, so I can do either OLS matrix YX, and if you pay attention, it's the same value as it's not the same value as the previous model, because here I made a mistake. Here it's not miles per gallon, then that's why I have a perfect relationship here, right? So it's the weight, so I changed that. So now I see the X, there is. So now I see the coefficients again from the first model. And then I run the OLS mat function again, and now it's the same, but in matrix form or as a column vector. But if I call the OLS double function, it's really similar, but the output, it's not a matrix, it's a vector. And there is. So I'm obtaining the same as the LM function, right? So this is just to show the basic idea. So then, if I want to do something different, I can go here, and let's say I want to do a QR factorization. I can search for the QR factorization here, right? And this has a search bar here. Okay, it's taking a while to load. Okay, I'm going to expand this to the side. Here, I'm going to open the vignettes. Okay, here we have the Koleski factorization. But we also have the QR factorization or decomposition, and we can use either this one, the classic one, or we have the economic one, like this. So I can copy this example, right? And I can open the editor here, and I can just copy and paste this file. Then I can rename it, and I can rename this to, let's say, more OLS. Okay, so here I can copy this part of my example, the QR factorization, and I can even open this with a notepad. I know my stack is not the most technological one, but here, let's say I call this OLS QR, and I like to do this way to separate like the core function from the wrappers, like the R wrappers. So I'm going to delete that one and just export a matrix output for the example. And this is going to be OLS QR matrix. Okay, Control S, it works here. Okay, it's good. So here, instead of directly inverting the matrix, which can be risky because of numerical instability sometimes, I can just comment that, and here type save option, use QR econ, right? That's the economic QR decomposition. So I paste my example, right? And then I define two matrices, Q and R, to store the factorization result, and then a boolean okay, that's going to be true if the decomposition worked, or false if it did not work, right? And X, it's a matrix I have already defined before here, right? But I don't need X, I need this one, X transpose X. So I pass that here, right? So then I can type like if okay, then here a small homework, use Q and R to obtain the inverse of X transpose X, right? And this, it's like obtain this in an indirect way, right? And then get the OLS estimator for beta, right? So then you can complete the function and do the register process again and see if you obtain the same result. It's going to be the same result, but this is the numerically stable way. just in case the lm function internally uses the QR decomposition for the same reason, to avoid doing something risky like that. For example, if something is collinear, etc., etc. Okay, so if you do that, then when you complete this small assignment or homework, let's say, now what you need to do next is to go to the main script and then write like include and then 02, and this was called more or less .h because it's a header, right? So this header creates a single binary. Actually, you can see that there, right? So the make vars, don't touch this when you're starting with. It's provided with a template to make sure that R can link everything properly and that all the internals are a well-greased engine. So I like this approach because I have the headers, everything is modular, and you can also create many CPP files, but then that creates multiple binaries like this one. So look, this binary is 1.5 megabytes. So then if you have many CPP files, then the package it's too bloated. So I like this approach. Okay, and also here you call the headers one time, and right, and not on every C++ file, right? So that's it. You can conclude this and then try again. So I hope this video was clear. If not, ask me in the comments, email. So I hope it's useful. Thank you very much.